see my screen soon? Maybe, maybe not. All right. So let's see, diluted and percent concentration. Right. So can you guys see my screen? Perfect. Okay. So what I'm going to do is I'm going to have this over here, and I'm going to have, oh, that's weird. I don't know why that's like a brownish color. Huh. We're going to zoom out a little bit. It's like a interesting color. So I'm going to have this over here so you guys can see what I'm going to write down. Okay? So dilutions, all right? What does it mean to dilute something? Basically, all you're going to do is you're adding water to it, okay? All you're doing is you're adding water to dilute something, all right? And have you ever performed a dilution? Just a question, all right? Now, and this is what we talked about. So oftentimes companies sell a very, very concentrated solution, all right? And it must be diluted to a less concentrated, which is molarity. So we are analyzing molarity today, all right? And hopefully we remember from last week that molarity is equal to moles over liters, okay? We know that molarity is equal to moles over liters. But today, calculating dilutions, what the equation is going to look like, I'm going to zoom in a little bit. The equation is going to be M1 V1 is equal to M2 V2. So if you could write that down, that equation real quick, that would be fantastic. The M's are molarity, obviously. And the V is actually the volume. Okay, and usually the volume is in liters or milliliters. Okay, so that's our dilution equation. The 1 means that these two are connected to the initial solution. So the 1s mean it's initial. So what does the initial solution look like? And what's the product look like? It's kind of like reactants and products. What's the initial and what's the final? Okay. So there we go. What an example problem looks like is here. Okay. If 100 milliliters of 6 molar NaOH is diluted with water. Okay, so I have my initial materials. I know my initial molarity, M1, is 6. My volume is 100 milliliters. I'm given that. Okay, I'm going to erase this for now. And then on the right-hand side, let's see what I'm doing. Is diluted with water to 800 milliliters. So my final product has 800 milliliters. I have to solve for molarity. Okay. How would you think I would solve for M in this problem? I'm sure you thought of it. All right, so I multiplied these two numbers. So 6 times 100 is 600. It's equal to 800 M. And to get rid of the 800, you have to divide. So I'm going to move this up. 600 divided by 800 is 0.75. All right, and that is how you use this equation. All right, you look at the molarities, you look at the volumes, and you multiply and divide. Okay. Hooray, we got the right answer. Okay, so let's try another one. What volume? Oh, what volume? So I have to look at my equation again. So M1V1 equals M2V2. I'm going to write that down on the next page over here. M1V1 is equal to M2V2. So what volume? It's asking for my initial volume. Okay, so I don't know what V is. Of 12 molar HCl. Well, I know my molarity is 12. And on the right-hand side is needed to make 1 liter of 3 molar solution. So I'm given 3 molars, and the volume says it's 1 liter. Okay, so all you got to do is 12 times V is equal to 3. So the opposite of multiplication is division. I knew you guys knew it. So my volume is equal to 0.25 liters. And that's how you solve it. All right, just a little multiplication, a little division. Okay. I want you to try one example on your own. One example of your own, real quick. All right, M1 V1 is equal to M2 V2. Oh. Does anybody have an answer they would like to share? All right, well, let's try this one out. All right, so my equation is M1 V1 is equal to M2 V2. And if you look over at the problem, it says 25 milliliters. So that's my volume. So 25 is my volume of a concentrated acid, 17M. So I know 17 is my M. Are pipetted in a flask. Water is added up to the 100 milliliter mark. So my volume in the final product is 100. And all I have to do is solve for M. Okay, so you're going to multiply those two numbers together. I need a calculator. Multiply those two numbers together, and then divide your final answer by 100. And the molarity I got was 4.25. All right, is that what you guys got, hopefully? Is there any questions on the dilution equation? All right, there's one other thing I want to show you real quick. And what it looks like is percent concentration, okay? Percent concentration. Now, what this does is it tells you the percentage of a solute in a solution. Oh, all right, so this is some terminology that I know we know. Solute is a solid, okay? The percent of solute in a solution. Well, the solution, all right, so solute is the solid. I know we know that. The solvent is the liquid. I know we know that. But the solution is actually the solute plus the solvent. So it's the solid and the liquid create the solution. okay? So it tells you what percentage of the solute is in the solution. Okay, and this is the equation. So I want you to write this equation down real quick. So the equation is percent concentration is equal to the grams of the solute over the grams of the solution times 100. Okay, so we're going to try this out real quick. We're going to try two examples. All right. What is the percent concentration? Ooh, percent concentration. That's what we're solving for. What is the percent concentration of a 1,200 gram solution that contains 875 grams of solute? Okay, so in my equation, percent concentration is equal to the grams of the solute. Well, I have 875 grams of solute. All right, over the grams of the solution. Well, grams of the solution is 1,200 times 100, right? So I'm going to plug this in the calculator real quick. 875 divided by 1,200 times 100. I got 72.9%. So I'm going to round to 73%. And that's how you solve these problems, okay? Grams of the solute over the grams of the solution, okay? So let's try one more. What is the percent concentration? So once again, we're using this equation of a solution that contains 50 grams of solute and 200 grams of solvent. Okay, so let's write out our equation again. So I'm going to have the grams of solute over grams of the solution times 100. Okay. So in this problem, grams of solute, it tells me grams of solute was 50. Grams of solution. Wait a minute. It doesn't tell me grams of solution. It does, however, tell me, I'm going to go up to this. It does tell me I have 50 grams of solute plus 200 grams of solvent, right? So how many grams of the solution do I have? If I know the solute and I know the solvent, well, if I combine those two, I have 250 grams. And that's my solution. I have 250 grams of solution because solution is the solute plus the solvent. Where the solute in this problem was 50, the solvent was 200, and that's how I got 250. All right. So now, once again, you plug it in your calculator. 50 divided by 250 times 100. I got the answer to be 20%. Does that make sense? How do we feel on that? Two new equations. All right, do you guys have any questions on that? All right, so if there are no questions, what we're actually going to do next is I did post a little activity on Google Classroom, okay? And it's just a few problems, not too many. And I want you guys to try